based on my impression, if I use F-test here, if I use regression here, if I use A priori here, this one 0.15, this one 0.05, this one I put 80, and this one I put 3. Based on my impression, I will get a total minimum sample size of 70 to 80. Okay, 70 to 80. Not 300, 400. That's why this afternoon you will see why big sample size can also be a problem. Okay? So, about 70 to 80. Now, 2 things you need to remember. Number 1, when it says 80, the application is telling you this is the minimum sample size. So when you collect your data, make sure you collect more. Why? Because there will always be some completed questionnaire where you might have to throw away in your cleaning and screening process. Okay? So please don't take the risk. You collect only 80. Okay? Collect more. Collect 150. Alright? Because who knows? Things may you may have to throw many things away. Okay? Number 2, remember what I said earlier about unobserved heterogeneity. You did not anticipate the difference. But when you run the results, but when you do the testing, the results are strange. They do not make sense. And when you run your t-test, then you realize male and female are very different. Okay. You only collect 120. 120 is more than 80. You thought you are safe. But because of unobserved heterogeneity, you decide to split your data into male and female. But when you split your data into male and female, male 70, female 50. In that case, you fail to fulfill the minimum sample size of 80. Okay? So be careful. So this application is telling you, if you have a model where you have 3 independent variables and 1 dependent variable, and assuming that whatever you key in here is correct, about effect size, about error, about power of 80%, the application is telling you that a minimum sample size of data from 80 valid respondents would be enough to hold statistical power to explain your model. And your model is 3 independent variables affecting 1 dependent variable. So it's about explanation. Okay? It's about statistical power to provide enough explanation to your framework, to the phenomena that you are investigating. It doesn't matter what it is about. Okay? The software only recognizes the figures. Okay? You as a researcher, you have to explain. Alright, sorry, I have to explain to you using the slide. I cannot show you how it is done. But if you have downloaded, if you have installed, play with it, give it a break. If you have any question, let me know. Okay? So this is power analysis. Okay. Now, let me show you another thing. Okay. This morning we are going to cover factor analysis, but we will do it after the break. So there are a few things which I need to explain to you first. And also, if you have any question, feel free to ask. Right? Now, sorry, wrong slide. Okay, can you open data analysis slide 2? Okay, can you open data analysis slide 2. If not, you can look at the screen. Okay. I hope you. Okay. Okay. Can you see web power? Phil, can you see web power? Okay, thank you. Alright. Now, few days ago, we learned about skewness and capacities. We learned about Z-score. So these are univariate normality, univariate outliers. Okay. But when you have a model more than two variables, and these variables are interacting with each other, okay, then you cannot use univariate anymore. You cannot use bivariate. Bi is for two variables. If you have more than two variables, you have to use multivariate analysis. Okay. Yesterday, when we do t-test and ANOVA, we tested four variables, right? Attitude, subjective norm, PVC, and intention. T-test and ANOVA are still considered as univariate analysis because when we tested on these four variables, we did not test on their interaction. We test these four variables one by one. What we did yesterday is we put them together one go so that we get the result for four variables. You can do it one by one. When you put them together, what the analysis did, it also produced results one by one. There is no interaction between attitude and intention and subjective norm and PVC. There is no interaction. The moment when you have interaction of more than two variables, 3, 4, 5, 6, then you have to look into multivariate analysis. Okay? Multivariate analysis. So this afternoon we will look at bivariate correlation, which is bivariate analysis, and then we will move on to regression, which is multivariate analysis. Okay? Now, since most of you, maybe all of you, will be using regression, this is a very good and very user-friendly online calculator, okay, to check your multivariate normality. Okay. Oops. Okay. I will try to show you how it is done. Let me copy. Okay. Hold on. Let me copy the web link. Where is it? Okay, this one. Okay, I will show you the website. Hold on. Okay. Now, can you see the website? Oops. Okay. Okay. So this is the website. Alright. Okay. This is the link. Alright, the URL. So very simple. You just have to put this in. Okay, put this in. So the first one, upload or select a file. So what you do? Choose choose file. Okay. Make sure I save my file yesterday. Okay. Okay. All right. So can you? Okay. Sorry. Again, can you see the web power?
Yes.
Okay. So choose file. If you click choose file, can you see the pop up?
No.
Cannot.
No.
Okay. So when you do this, okay. Now you have to upload your file. Okay. I don't know where you keep your file, so I will look for mine. Okay. I keep my file here. Still, can you see me highlighting data analysis exercise 3?
Yes.
Okay. Alright, so I will upload this to the software. Okay? I will upload this to the software. Now, can you see now that I have uploaded my SPSS file here, right? Alright. The next thing you need to do, just tell the application which type of data you are using. So in my case, SPSS data. Finish. Okay. Then tell the software which variables you are using. For example, 1, 2 to 5, 7 to 9, all this. Okay. So how do you tell the software? Okay. Again, go to your SPSS. Oops. Okay. Go to SPSS. Okay. Let me stop share and share the screen again. All right. Can you see my variable view?
Yes.
SPSS. All right. Scroll down. Okay. Remember, these are the variables, right? Entity, SN, TBC, and IT, right? So you just tell the software 59 to 62. 59 to 62. That's it, huh? So let's go back again. Let me stop share and share the screen. What is it here? So you just tell the software 59 to 62. 4 variables. Why? Because there will be interaction between these variables. Alright? Is there any missing data? There is no missing data. Alright? So you can ignore this. Click calculate. Okay, click calculate. So just wait for a while. There you go. Can you see the result?
Yep.
Okay, that's good. Alright. Very simple. Just look at this one. Madia's multivariate skewness and kurtosis. Okay? We are more concerned with kurtosis. Okay? We are not that concerned with skewness. Why? We are not concerned with skewness. Why? Because, as I said before, it depends on your questionnaire. Your data will always skew to one side. Okay, your data will always skew to one side. If it is too obvious, for example, everything is 7, you would have thrown this questionnaire away already. You don't have to keep everything 7, 7, 7, 7, 7. Another copy, everything 7. Another copy, everything 7. You don't have to think twice. You just throw away. Okay. But for 7, 6, 5, 6, 7, 7, 6, 6, 5, that's okay. Skew to one side. Okay? Because of your data. What you can do is, you can do reliability tests. For example, as I mentioned yesterday, you purposely put a negative worded statement. Okay, so if a person is rational, he should put 567, 667, 775. If you see 771, then that means this respondent is not reading. Then you can consider whether you want to throw the questionnaire away or not, because he might not do it properly. Okay, by chance he got some answers correct, but there are many weird data, right? So you can throw away. So in this case, what we are more concerned, we look at Mahdia's multivariate kurtosis. Okay, kurtosis. Okay, and here p-value is 0. What does it mean? When your p-value is significant, okay, this might confuse you. This might confuse you. When the p-value is significant, it means your data is not normal. Okay? So when your p-value is significant in Mahdia's multivariate kurtosis assessment, it means your data is not normal. Okay? Now, can you see the difference? Last week or maybe Monday, when we check kurtosis of attitude, kurtosis of intention, kurtosis of SN, kurtosis of PVC separately, all these 4 variables based on kurtosis result, they are normal. They are normally distributed. But when you look into multivariate kurtosis, when they interact with each other, the result shows they are not normal. They are not normal. Okay? So this afternoon we will learn a procedure called bootstrapping. Okay? So we will talk about bootstrapping tomorrow. So this is something that you can use. Not only this, because you will be writing your thesis here. All the references, the manual, everything here. Okay? Who says so? Okay, because if you say Hiram says so, your examiners don't care. So he is nobody. Okay, so look at all these references. Alright? So how the calculation is done, why is it important, and this is super important. Okay, by the way, because maybe for me, I'm quite used to submitting papers to better journals. This is something that you have to think. Okay, because when you run parametric tests, when you run Pearson by variate correlation this afternoon, when you run multiple regressions analysis this afternoon, one of the assumptions that you must make is your data normality. Not univariate normality, which many people did and reported. It is actually multivariate normality. Why? Because normal data times normal data, you will get data which is not normal because of interaction. Maybe those who have learned physics can enlighten us. You have one wave, another wave, and then when these 2 waves collide, it will go up. Okay? So that's why even if your data is normal according to univariate analysis, it doesn't mean it is normal when you run multivariate. I can tell you, based on my limited experience, whenever I run multivariate kurtosis assessment, I have never got a result showing that the data is normal. Okay? And remember, this is a simple model, just 3 variables pointing to 1. If you have moderator, if you have mediator, Okay, your data 99.9% will not be normal. Okay, so you can imagine how many people have got it wrong because they just proceed with regression. They don't care. SPSS will still get the result for you because SPSS is a tool. It is not a researcher. Okay, you have to decide. Just be aware, right? This might be something that you need to justify. You need to report. Okay. Now, how many of you have used the link I provided 2 or 3 days ago? Open Access, OMTD, Open Access Thesis and Dissertation. Okay, OMTD.org, I think org. Okay, so my general advice is you can use that platform to look for thesis which is related to your interests. Hopefully you will find 1 or 2 which are somewhat related to your study. It is always good to go through a thesis to get a feel, FEL, of what you will do. And from that thesis, hopefully you will get a lot of literature, citation, references, and also you get some ideas how to write your thesis. Now, thesis format, thesis guideline in Malaysia, in Taiwan, in US, in UK might not be the same. So you have to check NKUHT postgraduate guideline. But most of the topics, most of the subheadings, most of the contents, the idea, what should be written, are very similar. Okay? So my suggestion, if you don't know how to write chapter 3, methodology, or for some universities, it is actually chapter 4, okay, methodology, refer to this thesis to get some ideas. If you don't know how to report analysis, refer to this thesis and get some ideas. Okay, so this is my general advice. Number 2, you can also refer to journal articles. Now, when you write your thesis will have a lot more words than journal articles. Journal article, you only have 6,000, 7,000, 8,000, 9,000, maybe 10,000 words. But again, you can read in order to get references. You can read in order to get citation. You can read to see how the authors explain about their methodology, how the authors report their results. Okay? Let me show you a quick one before we move on to what we should be doing, what I plan to do today. Now, the article that I gave you in the folder, where is it? Exercise file. Material. Oh, sorry, it's not there. So, sorry, let me open. Anyway, I just find one example. Okay, you can, there are many articles anyway, so you can look for anyone which is suitable. So let me show you what it is. Where is the thing? Zoom, share, article. Okay. All right. So this is a paper again. My friends and I published last year. Oops. Okay. I wonder if you can see. Maybe it's a bit too. Okay. This will be better. Okay. Can you see the paper. Yes? Field? Okay, thank you. Alright? Okay. So, literature review, okay, for example, we talk about all the variables, and we talk about the theory, okay, we talk about the theory, alright, and then from theory and from past literature, we come up with our framework, and as I told you, in this particular paper, we don't have hypothesis. Not very often you see this, but this is a situation. Because again, it is about how you craft your story and make sure everything is consistent. Okay? So just imagine this is your framework and these are your hypotheses. So you show your framework and then you show your hypothesis. Okay? Now, this is how we explain in a journal article. For thesis, you may have to write more than this. You have to write more than this. Okay, for us, okay, we mentioned, for example, we are using reading subject experimental design, okay, and then we talk about the context of our study, because we are doing experiment, so we are doing an experiment on seafood restaurant, okay, how do you design your instrument, okay, so we talk about questionnaire, and we talk about scale, okay, not adopted, not self-developed, but we adapted, okay, adapted. And then we use 7-point Likert scale, ranging from strongly disagree and strongly to strongly agree. You don't have to mention what is number 2, what is number 3, what is number 4. Just say what is number 1 and what is number 5, or what is number 1, what is number 7. Okay, and then again you provide citation again to convince the examiners, the editors, the reviewers that this is supported. Okay? Okay, this is what I mentioned earlier. Okay, before data collection, a priori power analysis using G power, this was used. And this is the citation. 2007, and Hare, Hartwinger, and Susten, 2017. Okay? So in our case, we use 80% power, median effect size 0.15, and the result shows us that 85, a minimum sample size of 85 will be enough. Okay. Then we use this one, purposive sampling technique. Remember, this is one of the techniques under non-probability sampling. Okay. That is why I told you yesterday, it is a myth, it is a deviant teaching when you say non-probability sampling is not up to the right standard. Okay, this journal is considered a good journal in IS, Information System. So the editor, the reviewers have no issue with this, as long as it is appropriate, as long as it is consistent, it is in line with what your study is about and the situation with your target population. Okay? This study is about selfie promotion. Where can I get the list of every person who takes selfie in Malaysia? It's not possible. Okay? There is no list of selfie people. Alright? So again, okay, so since I use purposive sampling, I must explain what are the criteria. Remember? So these are the criteria, young adults, and they must spend time on social media. Okay? And also, these people must have some interest to food. Why food? Because the context of the study is seafood restaurant. Okay, so these are some of the criteria I set. Okay, so the experiment was done. Okay, here, okay, how it was carried out, how many students, and then I divided into groups.